Statistically Significant Mini Project 2. We're Team 18 and our engineering is mechanical. I'm Gunnar Howson.
I'm Chris McGovern.
And I'm Matt Figueroa. Alright, so for the distinguishing characteristics, mechanical engineering's primary function is to transfer energy from one form to another. Typically, mechanical engineers utilize the properties of the physical world in order to analyze and test their designs on a smaller scale. When it comes to statistics, determining the probability that a design would fail is a certain application, and typically we also like to analyze systems that have to do with motion, and as well as mechanical engineering is one of the broadest disciplines currently.
So a day in the life of an engineer, from the beginning of a project to the end of the project, every day is going to be compounding on the one prior to that. You need to empathize with your client and your customer and determine what their needs are. From that, you can define what you're going to create. You begin ideating and prototyping on a small scale. During that testing of the prototypes, the statistical analysis will allow you to determine whether you need to go back, re-prototype, and test again. You repeat that process until you reach a point of statistical significance that's allowable.
All right, so when it comes to talking about the grand challenges, basically one of the grand challenges that mechanical engineering is best at solving is the creating engineering tools for scientific discovery. So one of these things would be designing the physical systems of machines, and we like to use the example of the Mars rover. So in the Mars rover, you have to have different systems in place. So what mechanical engineers would do is they would work with the physical systems, and while the electronic engineers and the software engineers are making the actual components, the electrical components, what the mechanical engineers will do is they will create the housing for those smaller components, and they will test whether they will test the specifications of what they need to withstand. So if Mars has a certain heat level that the components need to withstand, they'll test that using different statistical analyses. As well as they'll test if certain parts will fail under a certain load, a certain environmental stress. And that's how they kind of work with different engineering disciplines to solve the tools for scientific discovery problem.
A second grand challenge would be restoring and improving urban infrastructure. Teaming up with civil engineers would allow us to assess one of the major challenges, which is transportation infrastructure. We can analyze the components, the materials, and small-scale structures that they're going to utilize to make the system more efficient. Statistically, we can analyze the efficacy of a new infrastructure by analyzing the reduction in motor vehicle fatalities. Increasing the sustainability of energy, water, and waste systems would be improving the mechanical efficiency of the system, analyzing the amount of reused groundwater, and how readily you're able to move waste from one point to another in a safe manner and store it.
The last grand challenge is provide access to clean water. Designing personal or communal water filtration systems for developing nations. The chemical engineers will test the efficiency of the filtration system, and the mechanical engineers would test the components and will create the tube that is used for the filtration. And the statistics would be the percentage of junk that's remaining in the water after it's filtrated. Percentage of population that could get access to the device in developing nations would also be another statistic. And reduction in the waterborne illness in nations without clean access to water after they have access to this filtration would be another statistic.
And here's our works cited page.